to listen to me blab on about JavaScript stuff. So I'm going to try and share my screen. Hopefully this works. Can everybody see my slides? Or okay, sweet, cool. So yeah, this is my stuff. Yeah, like I'm not going to really talk about this too much. If you want to, like, all these things are linked. So if you want to see more, there's my slides link at the bottom, kcd.im/beginner-asts-slides. Yeah, let's jump into it. I like to start out by giving expectations so that we all know what to expect, and you can drop out if this isn't what you were hoping it to be. Or you can tell your coworkers who aren't here, maybe they'll come. But yeah, I'm not going to be talking about or giving like a deep dive into parsing and tokenizing and lexing. Like, I don't even understand that well. And there's actually a talk that I referenced at the end of my talk about compilers by James Kyle. Super, super good. And yeah, this isn't everything you need to know about ASTs. It's a pretty big topic. So yeah. I am going to give a basic introduction to the concept of ASTs, kind of what they are, how they work, and how you can use them in a practical way. The demo I actually just last night made it more practical, so it's mostly practical demo of how to use ASTs with Babel and ESLint. And I guess the reason why it's only mostly practical is because now that I've created it, you can just copy what I've created. But it should at least teach you how to do things yourself. Yeah, it's super, super valuable. Yeah, and hopefully this gets you excited about what's possible with ASTs. So let's start with why. So why should we care about ASTs? Well, ASTs are what power Babel. So does anybody use Babel around here? Babel or TypeScript or even CoffeeScript, the good old days, or even like a preprocessor like PostCSS, or like even handlebars or stuff like that. All of these things use this concept of ASTs. And we'll get a little bit deeper into what these things are, but the value of these things are that you can take a representation of code and make that into something that is easy to manipulate, and then take what you've manipulated and make code out of it again. And that's what Babel does, is it takes the code that you write, the ES.Next code, and it converts it into something that is usable by the browsers or the other JavaScript environments that we're shipping to. So a couple of examples of this is Babel Plugin for Lodash. So Lodash is a really big module, and that's not a huge deal if you're doing Node stuff. But if you're sending this to the browser, then that can be a pretty big bottleneck. And so like most of the time, you're just going to say, like if you're using import statements, for example, you're going to say, I want to import the add function from Lodash-fp or /fp if like you just want to get the functional programming version of this function, or you just import all of Lodash and then you use it. And that's what the developer inside of you wants to do. But if you care about the user experience, then you should probably be like cherry picking the specific modules that you're actually using, so that you don't send all of Lodash to the browser, just the pieces of Lodash that are valuable. So what this Babel plugin does is it allows you to have an awesome developer experience by just importing things the way that you want to. And then it will transform it into something that's good for the user. So you're cherry picking the pieces that you want. And I think like that's a lot of what Babel is for, is or that's a big piece anyway, is making it so you can have a great developer experience without sacrificing, without your users having to pay for that developer experience. So you can author code in a way that's maintainable or makes it easier for you, but still optimize it using Babel plugins. So another one that does this, the same kind of developer experience improvement here, is if you have like a utils module that is like at the root of your application folder structure, and you're like deep down in directories, you have to import that. You have a bunch of //slashes, and that can be hard, especially if you move files around. You have to go update all of those. And so like sometimes I thought, oh, I'll just publish this to npm so I can import it like a normal npm module, and I don't have to do all these //slashes. Well, with this Babel plugin, you can actually configure it to have certain aliases for modules inside of your project, and then you can write your code as if it is like a node module kind of thing, and then it will transform it into something that's like usable by the environment that you're in. In this case, it would be like it transforms it into import statement, and then you need to transform that into like a require statement or bundle it with Webpack or something. But yeah, it makes it a lot easier. And then this one is also really, really useful. Remove prop types. So how many people here use React at all? React people? Okay, sweet. So prop types, you're all doing that because that's what you should be doing, right? Because it's good. So prop types are great, but they're not useful in production, and you should be building React in production with production mode turned on, so you're not it's not doing any of the prop types checking, and all of that code even is removed. But your code that you author with the prop types, you're still sending to the browser, and that's no good because like not only is that code useless because it's not actually being like there's no checking in production, but it also like is you're allocating space and memory for these objects here, which is suboptimal for performance. And so this Babel plugin, which you only apply for your production build, will actually remove the prop types. It works for like all versions of React components, but it like just removes them entirely. So you're saving on bytes that you're sending to the user, and you're saving on memory allocation for those objects. And so yeah, like this is yet another example of using a Babel plugin that's like where the underpinnings are ASTs. And making the developer experience great, but also the user experience doesn't have to suffer. So another thing that uses ASTs a lot is ESLint. And ESLint it's a linter, so basically it can look at your codes statically without actually running it and determine whether there are potential bugs in the program. So if this if statement has a condition that is never true, then like you can just remove that whole thing. That's a bug. Probably it should probably have some valuable condition or something. Or if you're not handling the error in a callback in Node or something, that's probably an issue you should handle. So ESLint will handle those problems for you. Another really great example of a plugin that has been super helpful for me is the ESLint plugin import, where I can like statically know whether I'm importing something correct. So like maybe I have a typo in the source of my import, or maybe I have like I'm importing something specific. I have an import specifier, but I have a typo in that, and so I'm not importing something that's actually exported. And so being able to see this statically without actually having to run the code is really valuable. And all of this uses ASTs. And then finally, Codemods. So a Codemod is basically like a find and replace that is really, really good. So I don't care how good your regex skills are, you will do much better writing like a find and replace with Codemod than with like a find and replace in your editor. And so the idea is it's basically like a Babel transform that you run only one time. And so like Babel normally you run as part of a build process. But like, let's say you have an API that you're using, and suddenly they add an argument in the middle of that function call or something. With a Codemod, you could find all the places where you're using that API and update it automatically. And it's just so much better than find and replace. And we'll see an example of that later. Codemods are super. Okay, so let's talk about what this AST thing is anyway. So code is for humans. All of the variable names in here, like this is actually a module that exists on NPM. It's called transformers names, and you can get random transformers names, which is kind of fun. Yeah, the fact that this variable is called unique random array matters to us because we know what that is. It has some semantic meaning to us. But for the computer, that has no real value. It just this could be A for all it cares, and that's why Uglify.js even exists, because the computer doesn't care what these variable names are, but we do, and we also like care about the formatting and the spacing, and that all that helps it so we can read these things. So this code is for humans, but when the browser loads it, or when Node loads it up, what it's going to do is it's going to parse it into something that it can have that's useful. And what that thing it parses it into is called an AST. So this is a code for computers. So that's that same code, just parsed with Esprit, which is the ESLint parser. And you can't even see it. Like, it's enormous. Yeah, it's a giant JSON object, basically. And what this is a representation of the code. So you could actually take this JSON object and create the exact same code using a generator that will take this AST and generate the code. So this is a representation of that code that we were looking at on this last slide here. But the cool thing is that, like, what if you could take some of these variable declarations that are represented here and move them to a different place by changing this JSON structure, and you can move things, you can remove things, you can rename things, you can do all kinds of weird things to this AST, and then you can generate code off of that modified or manipulated AST. And that's like the underpinnings of Babel, or you can analyze this AST and see that there are problems with it, and that's the underpinnings of ESLint. So let's look more at what this AST really is. There's this cool demo app from Joint.js, and this is actually what they're demoing is their framework for showing these cool diagrams, but they just happen to be demoing it with an AST, which is like perfect for our situation. So an AST, it's an abstract syntax tree, and so it's an object that is the data type is a tree, or the data structure is a tree. So in this abstract syntax tree, we have this program, and that's the whole thing. So we have a couple of variables, we have a function, we have a function call, and that's all of that together is a program. And this program has a body, and that body consists of these couple of things. So we have this variable declaration, another variable declaration, an add function declaration, and then another variable declaration in our code. And each one of these has properties of their own, and so on and so forth until you get to things that don't have any other properties. Right? So let's just look at this first one really quick, where it's a variable declaration that's var equals 42. It's representing this first item in our program. So it's index 0 in the program's body. And this variable declaration has what's called a variable declarator. And the reason for that is because you can actually have multiple variable declarators in a single declaration. So I could say x equals true. And if we show that AST, now we have that first variable declaration that is a combination of those two declarators. So each variable declaration has an array of declarators, and most of the time you'll have just like one declarator. But in this case, we have two. And for a equals 42, that's going to have a left side of the variable declarator will be our identifier of a, and the right side will be the literal 42. And then our other one, the left side will be x, and the right will be the literal of true. So let's modify this a little bit further and say like 42 plus 3 for our value that we're assigning to x. And now this variable declarator still has the left side of x, so the identifier, but the right side is a binary expression, and that's another node. And that node has properties, and the left side of that binary expression is 42, and the right side is 3. And so each piece of these nodes builds up this abstract syntax tree. And I should say that, like, you don't need to memorize all of these terms and these different, like, variable declarator or whatever. The more time that you spend with this stuff, the more experience that you have with it, the easier it is to really understand what's going on. The more valuable part that I'm trying to demonstrate here is that like the idea of a tree structure that represents our program. So let's take this one step further, and we'll add one more thing. We'll do, like, I don't know, math.pow 2 and 3. And so now this variable declarator is a little bit more interesting. The left side is still x, the right side is still a binary expression, but this binary expression now has a different left and a right. The left is another binary expression with 42 and 3, so that's that first part. So this is the left of the overarching binary expression. And then the right side is a call expression, and that call expression being math.pow. And because it's math.pow instead of simply pow, the caller is actually a member expression of math.pow, where the object is math and the identifier is pow. So that's how we get the math.pow part. And then the arguments for our call expression are coming from the literal 2 and 3. So I'm going to just stop really quick, and if anybody has any questions before we continue. But this is just kind of the basic idea of ASTs, is that it's this tree structure that represents your code. So anybody have any questions so far?
Yeah, I had a question. I was curious, how many different node types are there, and if they're all documented somewhere?
Yeah, that's a great question. So there are many node types. Let me see. I think I've got a. I thought that I had something in here, but there is like a standard. Let me just find something really quick. I'm actually creating an AST workshop right now, and somebody mentioned a resource that I think you would all find valuable. No, it looks like they didn't mention it, but there is like an effort to standardize on the AST format that maybe I'll find later. Yeah, so there, like, for pretty much every syntax feature that you can think of in JavaScript, there is a node type for that thing. So like imports and exports and function invocation, all that stuff. And as far as like, are these things documented? Unfortunately, for the APIs that we're going to be using, it's not all super well documented. It's lots of trial and error and console.log to figure out what's going on. But one of the really cool things about this is that it's all open source. So if it's not well documented, you can document it, and it'll be great, and we'll all be appreciative. Any other questions? Okay. Sweet. So yeah, so that's Joint.js, pretty handy tool. And let's see, there we go. Okay, so now like that graph is all cool and fun and stuff, but we want to actually manipulate stuff and make changes and whatnot and explore things a little bit further. So let's do that with this awesome tool called Ast Explorer. You'll find that at astexplorer.net. And here you can see on the left side is our source code, and on the right side is the tree. Let me bump that font size up just a titch. So right now I have autofocus turned on, so as I click around, the tree is being updated to the part of the AST that I have selected. And so you'll see a lot of identifiers all over the place. Identifier there, identifier there. Identifier is a really common type. It's basically a variable name. It basically has a type and a name. That's pretty much it. And it's commonly the leaf node. Well, it is a leaf node because it has no other children as part of it. But then also we have a function declaration here. We have a member expression here and an object expression. So there are like I said, there are tons of node types, and I wouldn't bother with trying to just like memorize them all or anything. It's more like the more experience you get, the more familiar you are with these node types. But that's the basic idea. Is here we have this let's go ahead and we'll start from the top. And right now we're using the Babylon parser. I should have showed this earlier, but there's a bunch of different parsers that can take this code and transform it into an AST. And they differ slightly, and so that's why there's an effort to try and standardize these a little bit. But as part of this tool, just kind of a fun fact, you can actually generate an AST for more than just JavaScript. You can do CSS, GraphQL, handlebars, HTML, SQL, I don't even know what IDL is, but I'm sure it's interesting, and YAML. So yeah, this tool is pretty awesome. And not all of these things can you transform something, and some of these only have a single parser. But yeah, for us, we have Babylon 6. That's what Babel uses. And then we can transform, and we'll look at that a little bit later. So yeah, we have now we have new code here, but with Babylon, we start with a file. That file has a program, and that program has a body. That body has two elements, a variable declaration, and you'll notice it's highlighting over here on the left as I select these different things. But yeah, I have a body with a variable declaration and a function declaration, and I can go down into there all the way down to these leaf nodes where they have no more children, but like it goes for a while. So kind of fun stuff. And that's this tool that we're going to be spending a bit more time in. So anybody have any other questions before we jump into that? Okay, sweet. So let us do that. How do we use these ASTs? So let's start out by making a Babel plugin. And I'm actually going to pull up the complete version so I can reference it just in case I get lost, because I don't want to waste your time. So here we have this, this code here. And this looks a little bit different than we had before, and that's because I have this transform thing turned on. So now we're transforming it with the Babel version 6 API. So we see the source code, we see the AST, and we see our transform code, which I'll talk about in a second. And then we see the transformed code. So this is our plugin. This is the code after our source goes through the plugin. So right now you see like nothing interesting is happening here. But actually, if I go here, I have another one that I already had pulled up that is kind of interesting. So we can explore what this Babel plugin thing is all about. So here, like the Babel Plug-In API is basically a module that exports a function, and it gets past the Babel object. This Babel object has a bunch of things that help us traverse the AST and like manipulate it and that kind of thing. And I should say that like you should think of transforming an AST like you think of making manipulations to the DOM in the browser. So like it's actually, some of the APIs are kind of similar to jQuery. And so like you have this idea of a selector. You say what you care about, and then you can like get properties off of it, and you can make changes to it. And you can think of your AST as kind of like a DOM where you can make manipulations to it. And so here we have Babel. That could be like our jQuery, and that has some utilities for us. And then what we return from our plugin is a name of our plugin. I think that's mostly useful for debugging. It's not really totally necessary. But then another property is called visitor. And this visitor is an object that implements the visitor pattern. So let's talk about that for a second, because that's pretty important as well. So if you were to try to write Babel, I guess, if you wanted to manipulate this AST by hand, then you would have to, like, let's say you wanted to change all of the, well, here, that's what this thing's doing. We're taking all the identifiers and reversing them. So here now tips is now spit, and print tips is now spit turnip. Yeah, it's backwards. So not really practical, but that's what we're doing here. So let's say we wanted to go find all of the identifiers in our program and reverse their name. So we'd have to start at the program, and we'd go through the body, and then we'd look at like pretty much everything in the body. And if it's a variable declaration, we have to go through the declarations, and then we go through the variable declarators, and then we find the identifiers, and then we find the init, because that could have some identifiers in it. And like it is a real mess. It would take forever to write something. And so Babel provides the visitor API that allows you to say, like, you go ahead, Babel, you go ahead and traverse this stuff. And whenever you come across a identifier, I want you to let me know. call this function, and I'll do something to that identifier. So that's what the visitor pattern is. It offloads the traversal of this AST to Babel, and then Babel will call into your functions whenever you want it to. So here we have this print tips is an identifier. That's the type. And so that's what we use in our visitor. We say identifier, that's going to be a function that accepts a path. I should ask really quick, how familiar is everybody with ES6? Just raise your hand if you know ES6 pretty well. Okay, so kind of a little bit. Okay, cool. So yeah, because we use a lot of ES6 in this stuff. I don't know how to not write ES6 anymore. It's hard. Yeah, great. So we have this path, and we take this path object. Here, we'll console log path, and I'll pull up my browser here, or my DevTools. So we'll run that again. And so every single time while Babel is traversing this AST, whenever it comes across an identifier, it's going to call our function with a path that has a reference to that identifier, as well as a couple of helper methods to manipulate the AST at that node. So if we look at one of those, we see a whole bunch of stuff in here, and on the prototype of the path, there's a whole bunch of functions. I don't even know what half of these do, but because there's just a lot to it. But one of the things on here is the node itself, and so here we're seeing the name is spit because it's been changed from tips to spit, and it has location information and what the type is. And so we can make changes to the node. We can manipulate the node based off of this information. So in our case, we're saying, hey, get me the node, get me that name, and I'm going to assign that name. I'm going to manipulate that to the reverse version of that name. That's how this particular plugin works. So before we go and write our own plugin, does anybody have any questions about this? Okay, nada. Cool. So yeah, let's go ahead and write our own plugin. So this get version function is super cool because it allows me to take a string of semantic version number and get the major, minor, and patch off of that. And one of the things it does is it creates a regex here, and I'm going to remove that real quick. It creates an inline regex here, and then it execs off of that. So one thing that we could do to maybe optimize this a little bit is move that variable declaration to above the function. And now like everything works exactly as it did before. Oh, this is the solution. Sorry. Don't look here yet. Okay, cool. No solution. Yeah, the reason that we want to keep the version regex inside of get version is because as a developer, it's a little bit easier to think about this code when things are closer together, right? So you don't have to look throughout the whole file. Like especially as the file grows, like right now it's not a big deal, but if this file were a couple hundred lines long, it's nice to keep things close together. But potentially this could be less performant than if we just allocated the memory space for the regex once and then never worried about it again because it's never being changed. So we want to write a plugin that will do this for us so we can have the developer experience we want, but the performance, like optimized for the performance that we need for our application. So yeah, let's go ahead and do that. When you start writing a plugin for either Babel or ESLint, when you start using the visitor pattern, what you start out with is trying to identify the nodes that are important to what you're doing. So first off, we'll click on this regex here, and we'll look over on this side and see that the type of this node is a regex exp literal. And so anytime we run into a regex exp literal, then we want to make a change to that thing. Okay. So let's go ahead and add that to our visitor, and we'll get a path, and let's console.log that path to make sure that we're getting what we think we are. And let me bump that up a little bit. And it looks like I don't need anything but the console. So yeah, it looks like we are getting what we want. If we look at the node, we're seeing that pattern. It's the pattern that we're looking for. So so far so good. Now let's say that there was another regexp in here, like foo.test thing. Oops. Okay, so now we're actually getting 2 of these regexps, and we don't want both of them because we're not going to move this one. We could potentially like create a variable out of this and then move it. That'd probably be a good thing to do eventually. But for starters, we're just going to do a regexp literal that is the assignment for a variable declarator. So to avoid this situation, if we look at the unique aspect of this particular AST node, its parent key is init. But if we look at this one, its parent key is object. So we're going to filter these out by whether their parent key is init, because that would mean that it is part of a variable declarator. So we'll say if path.parent key is init. Actually, we'll exit early and we'll say if it's not, then we'll return. Okay, so now we're getting only one, and it is the one that we're expecting. So we can continue on with our plugin for this particular node. And there are a couple of things that we need to do here. So first, we need to, we can't just move it up here and just like call it good as it is. Here, let's move that back. Because unfortunately, there's a potential for like foobar to have version regex is like thing, whatever. And so now we have like a conflict. We're gonna things are gonna blow up. It's gonna be like a big mess. Or like there could have been a var version regex here with like hi. I don't know. Like programs are hard. And so we can't just say, hey, move this node over to here. We need to come up with a unique name and then make sure that that name is being applied to all the relevant usages. And luckily, Babel makes this really, really easy. Or I should say relatively easy. I don't want to say that it's like super easy because, you know, programming's hard. So the first thing that we need to do is we need to get a scope, because we need to, like Babel can generate a new ID for us, but like the scope, all these closures are an important part of our program, and we need to find the place that this variable is eventually going to be and generate a new variable name for that variable based off of that scope. So something that's unique in the scope where it's going to be. And so if we click here, we'll see this is the scope it's going to be in. And that is inside of the program body. So we're going to find the program node and use that, or we'll find the path for the program and use that path to generate a unique ID for us so that we can use. So we will go ahead and say program, and we'll take the path and find. So this is kind of like in jQuery, that'd be like parent, where you can keep looking up until you find the right parent. And so this is going to be parent, and parent is program. And now if we console log the program, we're going to see that if we look at the node, the type is program. So we found the program. So the root of our area of interest. And I should note that there are is functions for every type. So is variable, declaration, and so on and so forth. It's kind of handy. So we're looking for the program. We found the program. And now we're going to use the path to the program, this path object, to generate a unique ID for us. And the thing that we use for that is the scope property. The scope property is responsible for making sure it knows all of the references to all the variables in the current closure. And so for us, we are interested in actually generating a new variable within that scope. And the scope property has a prototype with a bunch of functions on it to create stuff for us. So one of those things is generate UID identifier. And that's exactly what we want to do. So I'm going to say program.scope.generate UID identifier. And this actually makes a new identifier node for us where its name is unique. And so there's no temp variable in our code, and so it can do an underscore temp. And that's kind of how it, like what Babel does for all unique identifiers is it does underscore and then the variable name. And here, if we actually had a underscore temp equals hi, then it's going to create a underscore temp 2 because that would avoid a conflict. If I had a temp 2, then it's going to create a temp 3 and so on. So it'll keep track of that for us. But temp isn't really a useful variable, especially if you're looking at like you're debugging this code in production or something. And so we want to provide our own variable name. So we could provide version regex like inline right here, but we want to apply this to more than just the version regex, right? We want to apply this to like potentially any regexp literal that's part of a like a variable declaration. So what we're going to do is we need to find out what the variable name is for this regexp literal. So raise your hand if you're comfortable with destructuring, because we're going to be doing some of that. Okay, cool. So this is going to be fun. We're going to make a destructuring pattern for the path. We're going to pull a couple of things out. So I'm going to go ahead and console.log the path so we know what to pull out. Because what we're looking for is the variable name. And actually, I just barely thought of this. This is probably a better way to do this. So we're looking for this variable name. And if we look at the AST, that's an identifier. And that identifier is part of a variable declarator. So if we say variable declarator equals path.find, so we're going to find another parent. Parent dot is variable declarator. And so now we have console.log our variable declarator. It is this one. And if we look at the node, it has an ID, and that ID has a name. So we can get, based off of this variable declarator, we'll destructure out the node, and that node has an ID, and that ID has a name. And we'll just call this original name. Now if we console log the original name, we're going to get version regex. Everybody follow that relatively okay, hopefully. Okay, sweet. So now we have this original name, and we can paste that in here instead. And so we're getting our version regex for our new name. So I'm going to, instead of console log that, we'll make a new name out of that. And so we've got our new name for our variable, and now we need to actually move this variable up there and rename all references to that variable to this new name that we have. So let's start out, here we'll just, let me delete that really quick. First, let's go ahead and rename everything in here to that new name. So we're going to use the scope in the get version function. And so, well, actually, sorry, let me back up really quick. So all that we really care about for this rename is this closure right here. Like we've already generated a unique name that's unique to the entire program, but we only need to rename stuff that's inside of this closure, so inside of this scope. And the scope of the node that we're currently on, so this regex literal, is inside of this closure. So we can use that to get it. And so we have that path, and we can get the scope off of that path. So if I console.log path.scope, and let me just get rid of that guy. Then we can see on the proto, there are a couple more functions that we can call. And one that seems particularly interesting right now is this rename function right there. So again, the scope is responsible for all the variables that are in scope, like everything that's going on that's relevant to the scope of our current node. And so that's why it has this rename function that we can use. So if we say path dot, let's get rid of this, path.scope.rename, I'll just tell you that the first argument is the name of the variable inside of the scope that we want to rename. And then the second one is the new name we want for that variable. So the original name and the new name. And now if we look, the new name here is actually a identifier object. So here, let me just console log that. New name. So it's an identifier object, and rename takes strings, not identifier objects. So we'll take that new name, .name property. There we go. And now if we look at our transform code, so far we have successfully renamed version regex to something that's unique throughout the program. So the last thing we need to do is move this to here. And unfortunately, we can't just say, hey, Babel, move this variable declaration to this other place. What you have to do is create a new variable declaration and stick it into the place you want it to be, and then remove the old one. You have to do that yourself. So removing the old one is actually pretty simple. We can say path.remove, and now it is, it's not the, remember that what the path that we have right now is the regexp literal. And so we're not removing the variable declaration, but we want to remove that variable declaration. So we're going to say path.parent path.remove, and that will remove the whole variable declarator, because after we remove the variable declarator, the variable declaration no longer has declarators. It just removes the const for us as well. So great, so we've removed it, but now our program's broken because version regex doesn't exist. So we need to actually create another variable declarator in the program. So to do that, we're going to basically make a copy of our variable declarator right here. And actually, you know what, we can just do, instead of path.parent path, we'll just remove the variable declarator. That'll be a little bit more explicit. Okay, so with this, if we console.log our program, we're going to see the program has a node that has a body, and we're going to stick something in this body. Remember, we're manipulating this AST. I keep wanting to say manipulating the DOM, because it's like really, it feels the same, kind of like you're doing a similar thing. And so here we'll say program.node.body, and that's going to give us these two things. And then we're going to want to unshift, because we want to put something at the beginning. We'll unshift something else. And the thing that we want to unshift is our new variable declaration. And we'll create that here. So to create a new node, we're finally going to use this Babel object. We've destructured off types, so that's babel.types, and we've given it the alias t. That's pretty common in the Babel ecosystem. So we'll say t, and the thing we're going to create is a variable declaration. We can't just do a declarator because it needs to be part of a declaration. So we'll make a variable declaration. And that variable declaration, creating that variable declaration takes two important things. First is the type, so let, const, or var. And the second is an array of all the declarators. So for us, I'll just start with var. And then we have this array of declarators. So we'll make a t.variable declarator. And a variable declarator takes the left side and the right side of the assignment expression. So the identifier and whatever that init property should be. So in our case, the identifier we have is the new name. And it is an actual identifier object. And so remember, the new name is an identifier object that has a name property on it and a type. And already we see that we have var version regex up here, but we want it to have some initialization. And so as our second argument to the variable declarator constructor function here is going to be the initialization. Here, actually, let's go ahead and we'll console log this so we see console.log the variable declaration. So it has an array of declarations. It has an ID, and that's our identifier that we created, and a type, but it doesn't have an init. And we want to initialize it with this regexp literal that we're currently visiting. And that has a node that we'll use. So we'll say path.node. And poof, it's done. So now we have this version regex at the top of our closure, and it's being assigned to this variable. And then it can be used inside of this function. And it won't be used anywhere else, but it at least will be used in that function. And we don't have to reallocate memory every single time we come to the function. So there's one last little step here, and that is we're assigning it to var, but we should probably keep the same variable declaration kind that it was declared with in the first place, just to make sure we have the same semantics and everything. So instead of var here, we're going to want the kind from the variable declaration. And so here we can go find the variable declaration pretty easily. I'll just actually copy that. And instead of variable declarator, I'll say declaration. And we'll say declaration. And here, instead of var, we'll say variable declaration.node.kind. And that will give us a const. And that's it. That is our Babel plugin. Good job, everyone. Any questions about Babel plugins? I've gone like way over on what I expected. Well, I practiced this and I went way over on my practice run too. But does anybody have any questions about Babel plugins before we get into linting? Okay. Sweet. So yeah, and all this material is going to be available after, and it's this being recorded, right? So cool. So we'll go through the ESLint plugin a little bit more quickly. It's actually quite a bit simpler example, and actually lots of the things you learn about in the ESLint plugin are similar to the Babel plugin as far as like traversal and stuff. So I'll just look at the complete and I'll walk you through it. Because yeah, lots of this is repeat information. So as far as like the API for ESLint, sorry, let me go back and talk about the code here, the thing that we're trying to lint against. So here we have an if statement, and then we have like this consequent, right? The consequent right here. So this is totally legit. You can do this. You can also do this. But you might, like some people who aren't familiar might try to do this and something else and assume that it's part of this if block, especially if they came from like Python or something, right? Where indentation matters. In JavaScript, indentation doesn't matter. So you're going to be stuck, and this is going to log every single time. And so that's why I generally like to say, hey, put blocks around all if statements, makes it very clear what's going on. And so, and that's pretty common. This rule, ESLint rule, already exists. I think it's in the core. But yeah, I'm going to show you how to write a simple version of this. So yeah, as far as the ESLint plugin API is concerned, it's a module, and here I don't think that it's like transpiled or anything, so you have to use module.exports. And then you give it some metadata about your plugin, so you can give a little bit of documentation whether or not this is fixable, and I'll talk about that in a little bit. As well as a schema. And so if your plugin takes options, like for example, if you wanted to say whether or not you want blocks, like you could say, I don't want to have a block if there's only one thing, or I don't know. That would be silly. Always have blocks. But yeah, you can configure ESLint rules, and this is how you accept that configuration in the rule definition. And then you provide a create function, and that accepts a context. And this context will help you not only traverse the nodes, but also report any issues that you come across. So then you have the visitor object, and this should look very familiar to the Babel plugin. In our case, we care about if statements. If we go down, and we care about if statements that have a consequent that is not the same as this if statement, where the consequent is a block statement. So we're looking for if statements that have consequence that are not block statements. And the same would apply for like else alert yo. We'd also want to probably do this for the alternate of an if statement. So in either case, we'd want to alert on that. Excuse me. So in our if statement here, we're visiting this. Instead of getting a path, we're going to get a node. And that node is the same as the path.node that we had in Babel. And so we can't we don't have all the fancy useful things that we had in Babel from the path, so we can't path.find whatever. But the context can help us with that a little bit. But here, and you don't need to do that quite as much with ESLint, at least not the manipulation part, except for the fix function, which we'll talk about later. But here we have this is block, and I just wrote this function here. Is block, it is a block if it exists, and sorry, if it doesn't exist, we don't care. But if it does exist, then we care that the type is block statement. So then if the node consequent is a block and the alternate is a block, then we don't need to warn about anything. Everything's fine, and we just return, we exit early. Otherwise, one of those two things is not a block, and so we're going to report on that and say, hey, reporting this node with the message, yo, why you no block? And that will give us this error message, and when we run the linter, and if this rule is enabled and whatnot, then we get that error. And so hooking this up into ESLint and creating a plugin is a whole other subject, a whole other talk. But that's the basic idea, is you inspect the node, and then you call context report if it doesn't look like you want it. That's the basic concept. And then if you feel like you're able to fix the problem for them, then you can actually provide a fix function, which accepts a fixer, which will help you to manipulate the text or the AST nodes, so that when in the case where they say, hey, I want you to fix all this code for me, then it will run your code and fix the stuff, and it's super awesome. But I'm not going to jump into that right here. So any questions about ESLint, its API, or how to do cool things? Okay, this is really handy. And at PayPal, we have several custom rules that are specific to our APIs. Like, don't use this module in this way because it does this weird thing. You can catch a lot of bugs. Pretty much every single time you have a bug, you should think to yourself, is there a way that I could prevent this bug from ever happening again with ESLint? And if the answer is no, then your next question should be, could I prevent this with a unit test? And if the answer is no, then could I prevent this with an end-to-end test? And then write that. Whatever the closest to the time that the code is run. And with ESLint, the cool thing is it happens before the code is run. So ESLint is a great way to prevent bugs from happening in the future. Okay, sweet. So finally, with the 5 minutes that I have, I'll go really kind of quicker on this one. Codemod. So there's actually a tool called JS Code Shift that is really awesome, and it has a really jQuery-like API itself. But I've never really had much success using it. It's always been really confusing to me. And so Babel recently added this capability to have a custom parser and a custom generator. So the part that turns the thing into an AST, and then the part that turns the AST into code again. And so now you can use the recast parser and generator, which will preserve all of your formatting and stuff. And so now you can use Babel to code mod your stuff. So let's give an example of this. So here I have this Babel code mod example. And right now it is really small. Why is it so small? Is that font size okay for everybody? Oh, okay, good. So right now we're importing some stuff from some Node module or built-in modules in Node. But you may not be aware of this, but as things are progressing with a Node actually implementing ECMAScript modules, it turns out that this is not possible. So CommonJS cannot be consumed by ES modules with import specifiers. It just can't. It is reasonable to statically analyze things, but with CommonJS, everything can be totally dynamic. You can manipulate the module that exports in all kinds of weird ways. So yeah, this will not be possible when things actually, when things are native. And so we, like I myself have a ton of code that looks like this. And so we will want to transform this so that it uses just the default. So this is okay. This is definitely not okay. And half of this is okay. So we need to be able to say, okay, basically, let's take this resolve and turn it to path, and then go path.resolve, right? That's all we need to do. And then whoops, pretend that was that way all the time. But then we need to remove this and go down here and fs stop. But we don't want to have to do that all over our code base. That would take forever. So we're going to write a quick code mod that'll do that for us. And that too. Let me just commit fix thing. Okay, cool. So the way that things work is I have this plugin, and we'll walk through this plugin really quick or in a second. But as far as like wiring up all the tooling and stuff, I imagine there will be like somebody will build a CLI that will make this easier, but it's actually like pretty reasonable right now. All that you do is configure Babel, and right here I'm just configuring it with the Babel RC file, and I specify my plugins. I have I'm just referring to that plugin that I wrote here, and then my parser options using recast, and then in my package.json I have recast in here. I have Babel core so that I actually can do transformations. And then I have Babel CLI so that I can use it in my scripts. Okay, and then in the scripts, all that you do is say, hey, I want you to transpile all of my source, and I want my output directory to be right here. So it'll just overwrite all the files, essentially is what it's doing. So it's a one-time transpilation and overwrites the files. So let's look at the plugin really quick. Nothing too new here. We're looking for import declarations. We get all the specifiers, and we split it up between specifiers and default specifiers. And then if there's an existing default specifier, then we'll use that one. Otherwise, we'll create one. And then we'll find all the references using scope and update all the references. So all this magic, you can go look at it. It's a lot of fun. Yeah, let's go ahead and look at actually doing the transformation. So you could have a code base that's like literally thousands of little modules and write a, like how long, this is like a 46-line plugin with Babel and update it all. Whoops, Codemod. And poof, it's all updated like magic. Try to do that with regex, especially since here we had, if we go back, we had this resolve, but we also had this variable called resolve. Like try it, find, replace, resolve. Good luck. So yeah, this is awesome. Just update all the stuff, and you're good. So that's it. I'm like pretty much way over my time, I think. So sorry. Oh, I've got 1 minute, but I did want to leave time for Q&A. So I'm really sorry that I didn't leave too much time for that. But yeah, here are all the resources that you will hopefully find useful. Especially this how to build a compiler. That talk was really good. And the Babel Plugin Handbook, also a very useful resource. And it's teeming with opportunities for pull requests as well. So great. Here's that spec. So if you wanted to look at the effort to standardize, I think it's this ES tree spec thing. So, okay, yeah, and that's it. Thank you.
Awesome, Ken. Thank you so much. Will we have access to this slide? Can we get a copy of that?
Yeah, it's right here.
Okay. Oh, perfect. And I'm just going to write. Okay. So anybody have any questions?
How do I end this screen share thing? Oh, there we go.
Anyone? I see. Oh, Stefan?
Hey, Ken, thanks for your talk. It was very, very interesting. I was going to ask, I pretty much think you are aware of this new project, Prettier, that it's kind of going to replace standard, you know, that's like the standard formatter for JavaScript that I think was lacking for a long time, since many languages like Golang have their own formatter, like right with the compiler. Mm-hmm. And I just want to know, what are your thoughts there? I think that it's kind of interesting how Babylon is going to, I think, pretty much replace ESLint. And I think that is going to allow better flows. Like, for example, instead of letting you know what's wrong, simply correct it on the fly. For example, if you integrate that into your text editor or whatever. So what are your thoughts there with Prettier?
That's a great question, Stefan. So Prettier is an awesome project. I actually have a sibling project called Prettier ESLint that uses Prettier and then passes it through ESLint fix. So that you can, like, if you have existing rules that are fixing things, you can have one workflow for them both, and it's awesome. It's really, really cool.
I actually saw your comments on the issues. I know that, for example, I hate semicolons. So, but I know there are implications on the implementation. But this talk gives me like the initial tool for me to see if I can get that semicolon out of Prettier. So I pretty much thank you for this talk.
Yeah, sure. So on the subject of Babylon or Babel making ESLint irrelevant, there are like a wealth of rules that ESLint can check for, or things that ESLint can check for that cannot be fixed automatically. Like checking to make sure that you have handled the error from like a node callback, for example. Like, what do you want to do with that error? Do you want to like throw it, or do you want to like ignore it? Like there are so many things that you can't automatically fix, or even like a promise chain, like something that looks kind of funny. You may not be able to automatically fix that. And so I think that they're both very relevant. The concept of like Prettier is more about the formatting of things rather than the like semantics and the like the actual business logic of what you're doing in your program. So I see Prettier as taking and Prettier ESLint as taking over the formatting issues, and like Babel or ESLint taking over like making sure you keep bugs out of your program. So that's a great question, though.
All right, thank you. So I guess that the conclusion is that we're not going to get rid of that pipe, like formatting and then linting. So yeah, it's a great point. I didn't think about it before. Thanks.
Sure. Any other questions?
I think we might be good.
Okay.
So Ken, thank you so much. You really appreciate it. I know I see mind blown here on the comment. So I think you've made a really positive impact, and it's much appreciated.
Cool. Good. I'm glad.
Awesome. Thanks all. Have a good rest of your day.
Yep.
Bye.
Thank you. Goodbye.
Thanks so much, Ken. That was awesome.
Yeah, you're welcome. Thank you.